welcome everyone to the technology track. Let me do a quick sound check. Can somebody let me know that you can hear me? Yes, okay, great, thank you so much. All right, well, that was such an amazing talk. I hate that we had to cut it off a little short, but we do need to get started. Excited to have this lineup of speakers for you today. This block is focusing on some big ideas in 3D printing, in defense and energy, and also featuring some of the latest research in the printing technology and materials. So without further ado, let's pull Dr. Jennifer Wolk up on stage, if you don't mind, Abby. Abby is our digital ambassador, and she'll be here throughout this track to help you out. Abby Delaney, you can reach her in the chat. And I'll read Jennifer's bio as we pull her on stage. So Dr. Jennifer Wolk is a program officer at the Office of Naval Research. Her portfolio focuses on additive manufacturing materials and processes. And prior to joining the Office of Naval Research, Dr. Wolk was a senior engineer at the Naval Surface Warfare Center. So she has almost 20 years of research experience in naval materials and manufacturing. In her current role, she directs basic and applied research for a range of additive manufacturing materials and processes. She received her BS from Johns Hopkins and her PhD in material science from the University of Maryland, College Park. And with that, Jennifer, so good to see you, and I'll hand the stage over to you.
Good morning, everybody. Good morning. Hopefully you guys can hear me okay. So if you don't mind typing in the chat if I have audio, that'd be great. Thank you. Thank you. You know, this is always a fun experience to be able to reach out to a community like this. And I'm so excited to be here today to talk to you about the cool S&T that we're doing, and really to talk about how we can look forward into some of the S&T coming in the future, especially within this technology track. So thank you, Amy, so much for inviting me here today to chat. Let me attempt to get my screen up, and hopefully you guys will be able to see my slides. So hang on one second while I share the screen. Right. We're going to try this again here. Amy, I'm having a little bit of a technical difficulty. It's not showing my screen.
Let me do this for you then, and you just tell me when to go.
Okay. All right. Thank you so much. It's a good thing I sent you the slides early, huh? All right. So today I'm here to talk to you about how we can really change the paradigm, how we can break the paradigm with additive manufacturing. As Amy mentioned before, I'm Jennifer Wolk as part of the Naval Materials S&T division at the Office of Naval Research. So next slide, please. One of the things I want to do is to at least provide to you guys a feel of who we are in the Naval Research Enterprise. And we're comprised of the Office of Naval Research, the Naval Research Laboratory, PMR 51. And what we do is really look at investment from basic research all the way to demonstration and validation. And on this chart, you can start to see how we view different connections from both an evolutionary standpoint in science and technology as we make those steps moving forward one step at a time to that advancement, to that kind of implementation, and how we try to leapfrog in revolutionary technologies through our innovative naval prototypes, where we talk about experimentation, how we start to really prototype different developments. And so as we span evolutionary efforts in our future naval capabilities portfolio to our innovative naval prototypes, they're bounded on a basis of our integrated research portfolios. And these are connections from things like information and cyber, through our ocean battle space, the area I work in, and is specifically is in mission capable, persistent and survivable naval platforms. And then really looking forward to other battle spaces like warfighter performance and our aviation. And so as we look at our integrated research portfolios, as we span that evolutionary and revolutionary, and we look at basic research to demonstration and validation, these are areas that we in the naval enterprise start to touch, right? And you can imagine that additive manufacturing can touch in a lot of these areas also, right? So how do we utilize our technology to reach into those different spaces? How do we utilize additive manufacturing to push our bounds moving forward? And so if you don't mind moving to the next chart, Amy. Let's talk about where we came from. Let's take a step back for a moment and really explore our past. So on here, you see two images. The left image is from World War I, where we talked about the Liberty ships, and from World War II, in terms of the Victory ships. And as we look at what we were able to do in history, as we built these ships from kits, from materials that were available at the time, and at a speed to meet the need of our fight, right? To meet the need of the Americans at war during these times, right? It was a push to rise with everybody, with the people, to really develop technology. And so you can imagine those advancements, right? People said, oh, we can't do that. We can't even imagine having that many ships. But we had to do it for the fight that we were in, okay? And so if you look at these historical perspectives, you look at how manufacturing and shipbuilding looked in the 1910s, the 1940s, it certainly calls to mind, right, the infrastructure we had to put into place, the technologies that at the time were maybe a bit unsure, but we had to push ahead to be able to provide these platforms. So what does it look like now? What does it look like in a modern day shipyard? Can you hit the next slide for me, Amy? And so today, as we look today, we're looking at big advancements. We look at how we move large pieces of metal, large pieces of equipment. We look at integration. We look at how we can be able to leverage our infrastructure to the best of our ability and to continue to advance our platforms. But that's today. That's us right now. If you walked a shipyard, if you walked a manufacturing line, that's what it looks like today. What could it really look like in the future? Can you hit the next slide? How do we change that paradigm? How do we change for what our future looks like? And so this slide up here, as we take a step and pause and look forward at Industry 4.0, our future can look very, very different than that standard view of a shipyard, that standard view of what a ship looked like, right? And how that ship has evolved from the 40s to the 2020s, right? Our future, as we look at the embedding of different technologies and the connections of different technologies include autonomy. It includes our Internet of Things. It talks about how we connect all these different aspects, how we leverage big data, right? Big data requires us to first collect data to be able to build big data, right? To allow cloud computing, to allow things like additive manufacturing. And I think that this particular graphic really talks about the need of that connectivity to bring us towards that future of Industry 4.0. Okay, so if you can click to the next slide. So what does this mean for us for additive? So it means we can change the way we make things, right? Do we need that large infrastructure? Do we need now to really consider how our shipyards, our manufacturing plants, do they need to look the way that they looked before to take advantage of these tools and these technologies moving forward? So that's the question I would perhaps ask to you guys out in the audience, to ask you, is that what we really need? Can we change the way that we make things? And what I have here on this particular image is the Oak Ridge BAM, right? And this large scale printer really allows us to open a space we hadn't explored before in a size volume that we hadn't explored before. And this kind of size allows us to build very meaningful platforms. And so the image on the left is a 30% carbon fiber ABS plastic being deposited into a prototype structure. That prototype structure was a demonstration article of a submersible that we worked with Oak Ridge on. But it challenges us to say, how do we really design? Is this the way we need to design? And can we do things different? Can we do it better? So we're trying to push ahead with all these different connections. So while we look at what we've done in the past and the revolutions that we've made and the evolutionary technology that we start to push, how do we take huge revolutionary steps in terms of the way we make things? If you can click the next slide. So what does that mean for additive manufacturing right now? What does it mean for us? You know, it's awesome to see many names I really recognize here in the participants list and on the chat. And what I want to pose to this audience is, here's how we do additive manufacturing right now. This was done at Naval Air Station, Patuxent River, where they actually qualified a critical titanium part, right? And we were able to do this by leaning forward. And as NavAir leaned forward, the rest of the Navy leaned forward too. And it enabled us supply chain agility. It provided us an intermediate solution. We were able to take advantage of what AM allowed us to solve our problem. But we did it in a very conventional method. How can we change that paradigm from that conventional method of qualification? How can we change our mindset to push forward, to allow and fully realize the distributed manufacturing capability and our ability to rapidly qualify and certify a critical component? So here's how, one way that we think we can do it. So if you can move to the next slide. Conventional qualification and certification really is built upon the idea of building an understanding of our process repeatability and reliability, an understanding of our performance properties, and an understanding of our material. So I'm a metallurgist at heart, and all these things are very, very much linked to build our structural part confidence. But we don't always have that time. and that history with AEM parts and metals to get us there at a cost that's reasonable and a time that's impactful. So how are we going to do it in the future? And the way we're going to try to really do it in the future is to be able to leverage our computational tools, to look ahead, to break that paradigm of qualification and certification, to say, how can we utilize computational tools and sensors and controls to start to build that structural part confidence? And the program that we have over at Office of Naval Research is known as Quality Metal Additive Manufacturing, or Quality MADE. And what we're doing is really exercising that framework with these tools. And here's an example of how we're going to do it. Can you hit the next slide for me, Amy? We're looking at our models to provide us local detailed insights, to provide us an understanding of what's going on subsurface. What does it mean in terms of length or solidification behavior? How do we connect that to a process, to now understand a process regime, and to have an understanding of sensors, right? And those sensors can provide us insights into what those process shifts might be, whether or not something's really stable, right? As we look conventionally in qualification and certification, there's always been a very linear flow of information as we start to build it. How can we now bring together this information? How can we now take all these different aspects in the idea of building big data, infusing data in the Internet of Things, in our digital connectivity, to allow us rapid qualification certification? And so we need to push those bounds to be able to fully realize what we can do. And in this program, we've worked very, very closely for our technical authorities with other folks in the services to really address their concerns and answer those questions such that we don't have to maybe go sequentially, but perhaps we can really link and feed information when and where we need it for rapid qualification certification, right? That allows us to break a paradigm. That allows us to push forward quickly when we need to. So, but that's just one aspect, right? And the future, what does that future really start to look like? So let's go to the next slide, if you don't mind, Amy. That next slide talks about how do we advance our materials? How do we advance our processes? That future, that nebulous future where we connect through Industry 4.0. We have to start with the basis of an understanding to be able to develop this information, to build this information, to take from these fundamental building blocks of structure, of geometry, of materials, and understand what does that mean as we enable this broader implementation of AM. My hope when I talk about breaking that paradigm with AM is to provide enhanced capabilities with that broader design space, to allow us more tailored designs for material performance, to reimagine what that future of manufacturing maybe looks like, to really suit our needs. And so I'm gonna go to my last slide because I wanna leave you guys a bit of time for some questions in the chat and ask you, where do we go next? I lied, this is not my last slide, but, but where do we go next? So we can go to my last slide. I'll leave you with these words from Admiral Nimitz. Yes, there will always be a Navy, not necessarily a Navy of battleships or submarines or carriers, but a Navy in the sense of what the word Navy truly means. So I'll leave you with the thought of how do we remember and drill back to the essence of what we want to have, to not be bounded by what maybe exists, but to push forward, to allow us to say, what is the sense of what we really want to have? What is the sense of what this truly means for us? And where is the technology to enable us to do that? And so with that, I'll come to a close and hopefully answer some questions.
And so much. Your questions in the Q&A, and you can vote them up as well if you have like someone else's question. But while you guys are thinking of questions, I can go ahead and ask you something, Jen. What do you feel, besides, changing the paradigm and the thought structure around, the Navy organization that you work with, what do you feel are some of those bigger specific technological challenges? I know you're a material scientist, and maybe that's where your head goes. But
I mean, I wholly acknowledge my predisposition for different things, right? So what are the big challenges? In some respects, I actually think that there are cultural challenges, right, that are our biggest hurdles. How do we communicate and understand what people really need, especially in these times of COVID, right, where our connectivity is a little bit different? How do we understand what people really truly want to have? Do you have all these things because you always used to have these things? And do we really need those things? Or can we really drill down into what do we really need it to do? Right. And so I think that that's actually a big challenge, and understanding that intent. With AM, we have the ability to include design intent now, right? And so that gives us an understanding beyond our normal 2D drawings that said, it shall be investment cast and he treated to this value. I don't know why I needed to do that, but it said that. So we follow that. Now we have an ability to include more information, understand what they actually needed to do.
Perfect. Do you have a question? Dr. Wolk, you work with, I'm sorry, you do any work with plastics or mostly metal?
So while the bulk of my efforts perhaps lean more forward with metal, I do have other efforts in other materials, primarily related to the materials and processes piece of it versus an applications piece.
Are there specific alloys that you are currently focusing on?
Oh gosh, well, it's like asking what's my favorite child. And what I would say is I really tried to take a look at that spectrum and understand what those implications are for naval research, right? So there's certainly prioritizations within Department of Navy and interests within Department of Navy. I work very, very closely with my other colleagues from system commands to kind of discuss where they see that implementation.
What is your ideal? How fast, how easy, how inexpensive, how friendly, and each test sensor should be?
Can you say that again, Amy? I'm sorry, you broke up a little bit.
What is your ideal for how fast, how easy, how inexpensive, and how field friendly each technology should be?
Well, the answer to that is as easy as you can make any of those, right? And I recognize there are trades, right? But in an idealized situation, I would love to be able to push that bar all the way over to the easy button, right? Because I think that allows us that ability to solve the problem, right? It enables our people to solve their problem, right? So the easier any of these things can get, the better I think it is.
Awesome. All right, 2 more questions and then we'll break before the next talk. Are there specific calls for projects or funding from ONR for additive manufacturing?
Our calls from Office of Naval Research are always released on our ONR website. And it's a public-facing website. On it also provides the main interest areas that I have in terms of funding as of as of last year. So the ONR website is the most powerful tool to really understand some of those details.
All right, last question. What are some sustainability initiatives that you've seen within your AM work?
Ooh, sustainability. Oh, I can take this so many different ways, Amy. Okay, so sustainability, we talk a lot about sustainability and sustainment, right? So sustainment in terms of how do we keep our platforms kind of going, right? And so that often goes to the ideas of are there challenges in our supply chains to really sustain our platforms? Okay. Sustainability related to how do we look at that whole chain of manufacturing from recycling and other aspects, right? And I know this is probably like a catch-all, but it's all of interest, right? We have platforms that are aging. We have manufacturing lines no longer in place. We have materials that are harder to source, harder to come by. We have environmental concerns, right? So we don't want to just trash everything, but how can we really recycle that? How can we reuse aspects of that? So it's all important to me.
Awesome. Well, thank you so much. We do have to run. I appreciate you keeping us on time. We're going to break here just for about 30 seconds so you guys can get to other tracks if you want to, but then we'll be right back up. Thanks.
Well, thanks everybody for joining. I'm glad to connect to people virtually.
Awesome. Thank you so much.